This video is going to go over how to solve exponential and logarithmic equations. The first set of examples are going to be trying to get exponential equations to be of the same base. If we can do that, then we can just let their exponents be equal to each other. In this very first example, they're already written in the same base. So all that means I have to do to solve this is let the two exponential powers be equal to each other. And then this just becomes solving an equation like normal you would do in an algebra class. So I could subtract x on both sides and add 4 on both sides. If I do that, I get that 3 equals x. Let's look at this example here for part B. Now this is not written where the two bases of my exponents are the same. So let's maybe off to the side here look at powers of 4. So we have 4, we have 16, we have 64, and if I multiply 64 by 4, I get 256. So I'm going to replace 256 with 4 to the power of 4. And now I have the same base, so my exponential powers must be the same, and x should be equal to 9. There are going to be some examples in which you cannot find a common base. In that case, then you should see if you can use a base 10. If not, then you can just use the natural log. So if we take the natural log of both sides, then we can bring these powers in front using log rules. I'm going to then distribute this natural log of 5. I'm going to subtract and I'm going to factor out an x. I'm going to divide by this term on my other side. And that's going to be my exact number for my solution for x. You could plug that into a calculator if you wanted to find the approximate number, but I would just leave this as far as an exact number is concerned. All right, if I also have something of the form of e to the kt, then you would want to make sure that if you have a term in the front, you divide by that and then use the natural log like we did in this last example to undo the e power. What I mean by that is this first example, divide both sides by 20. And so you get 5 equals e to the 2t. Well, then I'm going to take the natural log of both sides. And this 2t comes in the front. Natural log of e cancels out with each other. And so I get that this must be my power of t. Again, I'm going to leave this in exact form. You can plug it into a calculator if you would like to. And then let's look at one that's a little bit more complicated. I would need to subtract 5 here first. Then I will divide by 4. If I take the natural log of both sides, I get that 2x is equal to the natural log of 7 over 4. And then I'm going to just divide by 2. And so that's my answer for x. Again, I could plug this in if I wanted to and find an approximate, a decimal answer. All right, what if our equation has a log in it? How do we solve for x if it's inside the argument of the log. Well, I'm going to solve this very similar to what I just did, where I'm going to try to isolate the natural log piece by subtracting 3 first. So 2 natural log of x is equal to 4. And then I'm going to divide by 2 on both sides. Now to undo this natural log, I can think of taking this to be e squared, or e to the power of on both sides is what I should say. Or if you remember from one of our other videos, this is the same as log base e of x equals 2. And so you can write this as base to the output has to be equal to the input. If you rewrite this in exponential form, notice you end up getting the same answer no matter which way you choose to approach it, whatever way works better for you. All right, if we end up having some logs that have multiple terms, then we can do a couple different things with their properties. So if we have logs on both sides, okay, we could take e to both sides to get rid of those logs. I'm going to have the x squared needs to be equal to 2x minus 3. Therefore, x squared minus 2x minus 3 is going to be equal to 0. And I need two numbers that multiply to -3, but add to -2. That's going to give me -3 and 1. And so I get x equals 3 and x equals -1. Now I want to be careful here because I cannot take natural logs of negative numbers. And so I want to make sure if I plug these in that I do not end up getting a negative number. I'm not really worried about 3. Like I think 3 is going to be an answer for sure. But let's just make sure with -1. Okay, squaring makes it positive. -2, 3. Okay, so these are both going to be solutions, but you do want to check with natural logs because if you were to plug in that x value and it gave you a negative inside your log argument, you wouldn't be able to include that in your solution set.